Hello everyone and welcome back to this next lecture. So in the previous lecture we had made that change to the reference definition for the ADC. So please do not forget that change which I made, because without that your ADC will not function correctly. And that, as I said, the worst part is it will not function at all. If it doesn't function at all, you might wonder if you made a mistake somewhere. But if it functions incorrectly, then that is really the worst part. So therefore do not forget the previous lecture where I had told you where to define the reference for the ADC. So in this lecture I'm going to execute this project on our microcontroller kit. So at this point of time I'll bring the microcontroller into the video. So you can see the microcontroller in the video and you'll notice that I made a few more connections. So for example, in the previous video I had showed that there were two connections which were from the GPIO pins to the resistor capacitor circuits. Now I am taking the voltage across the capacitor, which we had seen in the previous lecture were sawtooth waveforms, and feeding it to the analog input pins, which are basically the pins PA2 and PA3, which we had configured as analog input pins number 0 and number 1. And finally, I am taking the GPIO pins, that is pin PA4 and PA5, to two separate parts on the breadboard so that I can observe the pulses where we are trying to compare our internal voltage, that is internal analog signal, and generate pulses to have a comparison. So we are going to compare these pulses here with the actual pulses which are with the actual sawtooth waveforms which we will see here on our oscilloscope. So with this, let me zoom in to the oscilloscope because that's all we need to see. And let me adjust my camera a little. Okay, I think that's good enough. So with this, let me now execute my project. So let me go to production and make a program device. So it is exactly where it was where we left off last time, and therefore if I come here and just press OK hold, you will see we get exactly the two sawtooth waveforms that I showed you in the previous lecture. So it's exactly in the same position. So I'm going to let this run, and what I will do is I am going to leave the larger sawtooth waveform on, but I am now going to connect the other probe to one of the GPIO pins for comparison. So this is one of the pins where we are comparing this blue waveform, this particular sawtooth waveform, we are comparing it with the value 2. So our condition is when this waveform exceeds 2, then we are going to set the GPIO pin. And this is something, let us come and zoom in maybe a little. And if you take a look, you will see here that it is very clearly when this blue waveform crosses the second division here, that is when the pulse goes high, the GPIO pin. So this clearly shows that our comparison that is happening in our control code is matching with what we are seeing in the oscilloscope. So you see here the blue waveform is actually crossing 2 volts, because remember our division, the division for both channels is 1 volt per division. So which means the blue waveform is crossing the second division from our reference, and at that moment you will see that the pulse is going high. And similarly, when it crosses it and is on the way down, that is when it is decreasing, you will see that the pulse gets reset. So therefore our comparison is exactly as we expected. So let me just zoom out a little, and now let me check the other waveform. So in the other waveform we had done a comparison with 1.5. So let's have a look if that is also matching. So again, let me zoom in a little. So here again, if you take a look, our comparison was that when this analog signal crosses 1.5, then in that case we are going to drive the GPIO pin high. And if you take a look, this blue waveform clearly crosses at 1.5, and at that point you see that the pulse, the yellow waveform, is going high. You see this intersection happens very closely at 1.5 volts, because again, as I said, it is 1 volt per division. And you will see exactly the same thing happening here as well. It is in the midpoint of this division that both the yellow waveform is going low and the blue waveform is crossing it. So this implies that our analog extraction, we have precisely configured our ADC channel and we are able to extract the values and convert them back to 3.3 volt signals. And with those 3.3 volt signals, we can now execute our control code. So with this, I'm going to end the microcontroller video, or rather I'm going to end the oscilloscope video. And with this, we are also almost done with this lecture. Because remember, our objective of this lecture was to be able to configure the ADC channel to extract values from the pins at which we are receiving analog signals, to convert those pins into 3.3 volt signals. So we are basically taking the unsigned integer, which is the result of our conversion, converting it back to 3.3 volts. And there is one optional step which I said, if you have using any kind of measurement such as current measurement or voltage measurement or any other kind of measurement, you must look into the gains in these measurements and use those gains to convert it to actual physical quantities. So for example, if you're using a current measurement, you're using a Hall effect sensor, you can find out the gain factor. And if your signal conditioning circuit is also introducing another gain, you must take that also into account. With that, you will get the cumulative gain factor. And this gain factor you can use to change your signal to an actual current value. So this is the current which is flowing in the circuit. So with this, you will now have actual quantities with which you can run your control code, which means you can run a PI controller, a proportional resonant controller, or even some other advanced controller. Alright, so with this, I hope you got exactly the same results. I hope you are also able to get the exact same precise crossover between the two waveforms, that is a sawtooth waveform and the GPIO pulse. And in this case, I would recommend go ahead and play around with these values. Choose different values and see for yourself how the pulse changes and verify that you can accurately pick out precise locations of your sawtooth waveform, which would give you confidence that you have precisely captured your analog signal. And now if you write any control code, you are using precise values with which you can control your circuits to a fair good amount of accuracy. So if you have any doubts, if any of this did not work, if you faced any other issues, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture. Thank you so much for listening and goodbye for now.